Hey Honors Kids, welcome to Screencast number 2. This is on Charles' Law and Boyle's Law. We typically say the so-called gas laws, which include a few other things, but we're going to stick to Charles' Law, Boyle's Law. Okay? Now I'm going to show you a couple of diagrams. First of all, gases behave in a very specific way. The typical thing, actually I'm going to show you, okay, so this particular diagram could have been added to screencast number 1. But when we add energy and we increase temperature, a solid hits the point at which it begins to melt. It then melts and has become a liquid in its entirety. Its temperature continues to rise until we go ahead and we hit that point at which it's starting to boil, it vaporizes, now it's completely a gas. So that's what that diagram indicates. So the simple concept here is if you add heat energy, the temperature is going to go up. Well, one of the things that Charles' Law states, okay, I'm going to get rid of all of these so that we're not getting mixed up. One of the things that Charles' Law states, if I go right here, is assuming if we have temperature increasing on a gas and it's in a container and the pressure is constant. So the one important concept to think of is the metaphor, not a metaphor, the example to think about is a hot air balloon. So when you see a hot air balloon, this is what you think of when you think of a hot air balloon. But what you may or may not realize is a hot air balloon inflated looks like this, or in the process of being inflated. You see, it's nothing but a canvas balloon that isn't airtight, but it's got air in it. And what the pilots and the passengers on this hot air balloon want to do is they want to take these jets and they want to heat up the air inside that balloon. Because what happens when you heat up air particles, they move faster. The balloon has the ability to expand. So Charles' Law states that if we have a constant pressure, and what that essentially means at this point, we'll talk further about that, but when you increase the particle speed, the particle movement, that means that those particles are going to bounce off the walls of the container faster, harder, with more purpose, which is the pure definition of pressure. So pressure would naturally increase if you heat up a gas. But we're going to assume that the pressure is constant. And what that means is, going back to this picture, the balloon has the ability to inflate or change size. So while the pressure you would think it would go up, it's not, because the volume is allowed to increase. So what's happening with this hot air balloon is the air inside is expanding because we're heating it up. We're keeping the pressure constant. So what does that mean? It means the volume goes up. So the simple concept of Charles' Law is this. If we increase temperature, keep pressure constant, the volume will increase. And this is what the diagram looks like. This is what the graph looks like. If we keep pressure constant and we increase the temperature, volume goes up. So we have what's called a congruent relationship between volume and temperature. Charles' Law states you increase temp, you increase volume. Now Boyle's Law, on the other hand, is a totally different animal entirely. Boyle's Law, on the other hand, relates volume with pressure. So if I come back to this diagram right here, let me type in this, Boyle's Law diagram. Now, if I show you a diagram of Boyle's Law, this is a good one. Because what's happening in this diagram is we have a gas in this container. And if we go ahead and we push down on this lid right here, we keep temperature the same. Temperature is irrelevant. We say temperature is constant. Say it's room temperature, say it's colder than room, doesn't really matter. But as long as we just assume the temp stays the same, if I push down on the top of this container, the particles have less room to move and they will bounce off the walls more quickly, thereby increasing the pressure. And when that happens, we have Boyle's law illustrated. If you decrease volume, you increase pressure. Here's our diagram. We have an inverse relationship between volume and pressure. When volume goes up, pressure goes down. When volume goes down, pressure goes up. So that is an inverse relationship between volume and pressure. And the easiest way to see it is this. If I decrease the volume, the pressure goes up. See, the one thing that you have to know is that pressure, which is such a misunderstood concept in science, has to do with the it's the force in which particles hit the wall of the container. So think of it this way. Say this is a particle and it's hitting the wall of a container. I can hit it this hard, or I can increase the force in which I hit it. So force equals mass times, I'd write it on the board, but it'll look backwards. Force is measured by multiplying mass times acceleration. So if my fist was heavier, or if I move my fist faster, I can increase the pressure. So if particles are moving more quickly, they're going to not only hit the wall harder, because the acceleration goes up, but they're going to hit the wall more often, aren't they? And with the more often means an increase in pressure. So think of pressure as how hard and how often particles hit the walls. So if we go back to our two charts right here, actually let me show you this one. If we decrease the volume, particles hit the walls more often, thereby increasing pressure. Decrease volume, increase pressure. On the other hand, this one assumes pressure stays constant. So while we're heating it up and the particles move around more quickly, the temperature goes up, the volume goes up, but the pressure is staying constant because the walls of the container are getting bigger and keeping the particle impacts at a minimum. So that is an introduction to Charles' law and Boyle's law. Make sure you read a little chunk of the chapter if you're still having a hard time understanding some of the stuff that I said in this video, or rewatched little parts of this video again. I have a tendency to talk quickly, but the beauty of the video is you can pause me, listen to it again, rewind, etc. As an honors class, you're expected to take notes on this video, and the content found within is quizzable on Friday. All right, kids? I'll see you all.